Hello everyone, once again welcome to our channel Physi Dive, and this is your teacher Alex Rajan. Today we are going to study very important topic of class 10 NCRT, that is image formation by convex lens. So we'll see the different cases in the image formation for a convex lens, and we'll see what are the different properties of those images, the various pictorial representations in this particular image formation. So without wasting time, let us dive in straight to the class. So to the class. Image formation for a convex lens. About the convex lens, right? You can see that the representation of convex lens is like this, and we more precisely we call it as a biconvex lens. Why? Because two sides are there and two sides of a convex spherical surface together make this convex lens. So here you can see this is the pictorial representation. So the middle part, the midpoint of the lens is known as what? The optic center, represented by C. In some books you can see O also. It's up to you whether you represent it with C or O. Okay. And as you know, two sides are there. So two points here, and it is a principal focus. I'm just pointing it out F dash, and this one is F, and I'm just marking another point here, somewhere here. Okay, and it is, sorry, and this is 2 times the principal focus. And here also I'm marking another point, that is 2 times the principal focus, the second focus. So here, this is a actual pictorial representation. So in order to study the convex lens or the image formation by convex lens, we need to study 6 cases. Like that in the mirror, here also we need to study about 6 cases. And what are those 6 cases? 6 cases means whenever we are placing the object, then we need to specify the position of the object. And the first specified place where I need to place the object is at infinity. So I need to find out this case that if I place the object at infinity, where will I get the image? And the second position or second point is that if I'm pointing or keeping the object somewhere here, that is beyond this 2f, the point 2f. So the second point is that, or second case is that, when object is placed beyond 2f. If I'm placing the object beyond 2f or f dash, okay, beyond 2f dash. So where will I get or obtain the image for that particular case? And the third case is that if I am placing the object at 2f, if I'm placing the object 2f, object is A, B, okay, then where will I get this particular image? So this is the third case, that is at 2f dash. Okay. Now, what about the fourth point? My fourth point is that if I'm placing the object between 2f dash and f dash. So here also we will find out where will the image be formed. And the fourth and the fifth case, is that if I'm placing the object at f dash. So this is the fifth point at f dash. Now here we will see where will I obtain the object. And the last case, that is the sixth case, is that if I place the object between f dash and the optical center C. So where will I obtain the object? So that is this point. So by calculating all these 6 cases, we'll understand the basics of this particular image formation by convex lens, and then we'll study about the 2 cases of concave lens in the next class. So let us dive in one by one, straight to the point without wasting time. The first case, that is, if I am placing the object at infinity, where will I get the object? Let us see. And what are the properties of the image formed? So here comes the first point, that is when object is placed at infinity. So in the previous session of mirrors and all, we had already discussed the point, that is if an object is placed at infinity, then the rays coming from that particular point will be parallel to each other. It is not necessary that it should be parallel to the principal axis, but the rays will be parallel to each other. So if I'm taking, for our convenience, we are taking the rays are parallel to the principal axis also. So what happens there? So we had seen many conditions that if rays are parallel to the principal axis and if it is falling perpendicular to the surface, then through which point this particular rays will pass by. And we clearly know that the rays after refraction, they will pass through a particular point, and we call that particular point as what? The principal focus. As they are parallel to the principal axis, they will definitely pass through the principal focus, and if they are not parallel to the principal axis, then they will pass through either one of the foci. So foci are the points which are falling under the focal plane. So focal plane means it's a perpendicular plane in which the principal focus is present. Okay, now here you can see that both rays are passing through this particular point and principal focus, and we clearly know that if two rays, what rays? Refracted rays. If it is in the case of a lens, so the refracted rays are meeting together, and then there at that particular point of meeting, we will form or we will obtain the image. And here clearly, so you can say that the image will be formed at principal focus F, or at the point F. So here once again I'm saying, as these rays, ray 1 and ray 2, are parallel to the principal axis, then we obtain the points at the principal focus. So we are getting the image at the principal focus. And what are the different properties of this principal focus? Are they real or virtual? Okay, definitely we know that they are meeting in real, so they are obtained, or the image formed is definitely a real image. And we know all the real images are inverted. And the next thing is that, what about the size? We clearly know if the object is coming from, or the rays are coming from the infinity, then definitely that object is bigger. And here the points are intersecting at a point. In this case, at a point. And we can say it's a point size, highly diminished. Or we can say it is highly, sorry, this one is H, highly diminished. Diminished means very small. So these are the properties. If the object is at infinity, then the image will be formed at the focus. The object will definitely be real, inverted, and highly diminished. So these are the properties of the first case. And what about the next case? Next case means if the object is placed beyond 2f dash, what will happen there? Let us see. So here comes the next point, next case, that is when object is placed beyond 2f dash. One more point I need to make sure you all should follow is that make sure the focal length, this length and this length, that is the distance between focus and 2f dash, f dash and 2f dash, and the place between f dash and c, they should be equal. While drawing for the exam, it should be almost equal so that you will get the correct answer. Otherwise, you will go wrong. So definitely keep those things in your mind. Now, coming to the point, this is the object AB. So what happens there? So let us see what, I'm just taking two rays because the minimal number of rays that is required to form an image is 2. Okay, so from the point A, the first ray is moving parallel to the principal axis, and it is moving and it reaches the lens. So after refraction, you all know that thing, this is the ray. After refraction, it will pass through the principal focus. Why? Because it is parallel to the principal axis, and you know then after refraction it will pass through a point, and we call it as principal focus. Now you can either take these two rays, 2 points, 2f, f dash or f dash, and for my convenience I'm just taking f dash, or otherwise I can also take this the optical center. So here let us see what happens here. If I'm just drawing from this particular point, if another ray is passing through the f dash, then after refraction, what will happen? Definitely it will just pass parallel to the principal axis, and it will just pass like this. So this is what is happening. So you can see that there forms another point here. And if I'm just drawing the point here, you can see This point falls between F and 2F. F and 2F. As it is coming from the point A, this point will be A dash, and this point I'm just writing it as B dash. You can see this happens here. So what is the position of the image? So position of image will be between F and 2F. And what are the properties of that particular image font? The first and foremost property is that it is real, as both the refracted rays are meeting in real. So that is real, and all real images are inverted. They are inverted, and you can see it is just upside down, A dash, B dash. And the next thing is that, what about the size? You can see this AB is a bit larger than A dash, B dash. It is a bit larger. So you can say, which one is larger? The object is larger than the image. So you can say it is diminished, but it is not highly diminished, but it is diminished. Coming to the third property, that is when object is placed at 2F dash, what will happen there? Okay, let us see. So here comes the third property, that is when object is placed at 2F dash, what will happen here? So this is the most easiest property in answering, but it will be the most difficult property in drawing. Why? Because you need to get the correct point. Okay, you need to mention the correct point. So what will happen here? Let us see. Okay, just imagine that there is an object AB placed at 2F dash. So what happens here? If I'm just taking a ray coming from point A, then I'm just drawing it parallel to the principal axis. You know that after refraction, the ray will be passing through F. So this is the first case, and you need at least minimum two rays to get the image. So the next point is that either I need another ray which will be passing through the principal focus, or F dash, or otherwise through this C. So what it's up to you. Okay, whether to take which one is suitable, you just take it like that. Okay, now I'm just taking that, I'm just drawing it through C, so that you know after passing through the point optical center, then what will happen? After refraction, you will see that there will be no change in refraction. The ray will be passing straight without any deviation. Okay, so you can see that there is a point here. There is a point here. If I'm just drawing the point, you can see it is coming straight from this particular point, and you are obtaining a point here. Okay. So you are obtaining a point at 2F itself. So this is a point. That is, if I'm placing the object at 2F dash, then image will be formed. The image will be formed at 2F. So we clearly study the same case in mirror also. If an object is placed at the center of curvature, then we will obtain the same object, an image at the center of curvature itself. If you want to know it more clearly, I will pin it somewhere here. You can go through that particular video once again and revise it and come back. Then you will understand it more clearly. Both the things are same, but the only thing is that in one case, image case, it was a reflection, and now here it is a refraction process. So a small change, idea change is there, so concept change is there, otherwise everything is fine and same. Okay, so here if an object is at 2F dash, then the image will be at 2F. And what are the properties of 2F? What are the properties of image fallen at 2F? So first and foremost thing is that whether it is real or virtual, it is real. Definitely it is a real. So this is a real image, and all the real images are what? They are inverted. They are upside down inverted images. So here I will say this point is coming from this A dash, as it is coming from the point A, and this one is B dash. Okay, A dash, B dash is obtained there. And the next thing is that what about the size? The size, if I'm just closely seeing, both the size of AB and A dash, B dash are equal. So equal in size. They are same in size without any change. You will get the same size image if I'm placing the object at 2F dash. So this is the point. This is a third case. It's a very important case. The only thing is that you need to be a bit careful while drawing this ray diagram. Why? Because the image should be obtained at 2f itself. Okay, otherwise if you are drawing somewhere here or somewhere here, your answer will go wrong and you will lose the marks for the board exams. So make sure that you should be careful while getting this particular case. So here comes the fourth case, that if I'm placing the object between 2f dash and f dash, where will I get the image? And what are the different properties of that particular image? Okay, let us see an object AB is placed there. You can see in the diagram. Okay, so what happens here? I'm just taking one diagram or one ray. I'm just taking one ray passing from point A and is falling on the lens, and after refraction you can see there the light ray is refracted and passing through the point focus F. And then I'm just taking another point which is passing through the optical center without any deviation. It just passed by and it meets somewhere at this particular point here. Okay, just point is here. Okay, so if I'm just extending, then I'll get somewhere here. Okay, now if I'm just extrapolating, if I'm just finding out the image there, then the image is somewhere here like this. As this point is A, so this point will be A dash and this point will be B dash. Okay, now you're getting the image there. And the image is formed beyond 2F. So here, what is the position? So the position of the image is beyond 2F. Okay, and what are the different properties there you obtained? The properties are they meet in real, so you are getting a real image. So already the image is real. All the real images are inverted image. And the next thing is that what about the size? The size is magnified by just see. Look at the size of AB and A dash B dash. Here you can see a magnified image is formed there, so it is magnified. So these are the properties when I keep my object between 2f dash and f dash. So this is all about the fourth point. And the next point is that if I'm keeping the object at f dash, what will happen? So just see the screen. You can see that the object AB is placed at f dash. Here, a ray is taken and coming from point A, which is falling parallel to the principal axis and falling on the lens. So what happens there? You can see after refraction, it passes through the focus F. Okay, it goes like that. And the next point is that it is passing through the optical center. Here both, if you are observing, you can see that the distance between these two refracted rays are same. Same means what? They are parallel to each other. They are parallel to each other. So in mathematics, you know that two parallel rays will not meet at any point. But in physics, in the previous session of this mirrors, we had discussed the thing that is in physics, in optics, both parallel rays will meet at infinity. So definitely, why? Because we have already seen that the light rays are moving in the form of wavefronts, so they will definitely meet at infinity. So definitely two light rays, they are meeting in real. And what are the different properties? Are they meeting in real? Yes, definitely they are meeting in real, as we had seen that. That is, a real image will be formed. All real images are inverted images. And the next thing is that what about their size? Their size will be so large. Why? Because they are, just imagine that the light rays are meeting somewhere here and the image will be like this. It's too large. When compared with this particular AB, then definitely it will be very large. So we can say that they are highly enlarged. So these are the properties of the image formation when the object is placed at f dash. So without wasting time, the last and the special case of the image formation of a convex lens will be seen right now. So to the last point. So the last case is that when object is placed between f dash and C, where f dash is the focus and C is the optical center. So I'm just taking a ray. Here it is not F A dash B dash, it is AB. Now a ray is coming from point A, which is parallel to the principal axis. So definitely after a refraction, it will just pass through the principal focus. Okay. Now the next point is that if a ray is passing through the optical center, you can see that the rays are moving like this. Observe the refracted rays, and then you can see that they are not parallel. Instead, they are deviating each other. That is, at each point you can see the distance between them are increasing. That means what? At any point, will they meet? No, they will not meet at any point. They will not meet at any point. But we need to get the image there also, right? So in the previous session also, we had find a technique to find out the meeting or the intersection point or the meeting point. How? By extrapolating the refracted rays. So if I'm just extrapolating the refracted rays, you can see that if I'm just extending this particular first ray, then you can say I'm just extending it backwards. I'm just rubbing this one so that you will not get confused. Okay, fine. Now you can say I'm just extending it backwards and I'm just getting somewhere like this. And I'm just extending my second refracted ray also, then I can see that they are also moving and moving. And somewhere here they meet. It feels that they are meeting, or it feels that from this particular point, these two refracted rays are coming out. So we are saying that at this particular point they are meeting. Okay, and let this be A dash and let this be B dash. Why? Because this particular point is coming from this particular A, and we call it as A dash, and this one will be B dash. So they are not meeting in real. The only case in the convex lens where you will find out the virtual case, that is the image. So what about the position of the image? The position of the image will be, we can say that it is behind the the same side of the object. So here, what are the other properties of the image formed there, whether it is real or virtual? So it is definitely, it is a virtual. Why? Because it is meeting virtually. So it is a virtual image. All the virtual images are what image? Erect image. So you can see here also it is very erect. So it is just like this. Okay, straight. Upside, it's not upside down, it is straight. And the next thing is that, what about the size? So size, you can see here the object is this much, and but the image is this much. So we can say it is enlarged. So these are the properties. So there is a high chance for this particular case to be asked for your board exam. Why? Because this is the only special case in the case of a convex lens where you will get virtual image. And then there also the virtual images is erect as well as it is enlarged. So that's all about the 6 cases of image formation by a convex lens. So that's it, guys. I hope that you got the points, and it's very simple. The only thing is that you need to find out, you need to have that concept of the image formation by the mirrors also. Make sure that the distance between the optical center and the focus and the 2f dash or 2f should be equal, almost approximately equal. Then you will not find any difficulty, you will not make any mistakes there. It will be so simple. And the image formation by the concave lens is also so easy. We'll study in the next class. So we need your support as we are supporting it till now, and keep supporting by your like, share, comment and subscription. So we'll meet in the next class. Till then, goodbye and have a nice day.